This video is on dividing fractions and mixed numbers. So we've been doing a lot of multiplying of fractions and mixed numbers, and this is very similar. There's one key difference that we'll point out. So the first thing we need to look at is this vocabulary word, reciprocal, okay? Hopefully you've heard it before. So it just means flipping the numerator and the denominator of a fraction, okay? So flipping numerator and denominator, the top number and the bottom number, trading them up. This is going to be important for when we're dividing our fractions. So just to practice, the reciprocal of 1/7 becomes 7 over 1, or that's just 7. The reciprocal of 12, well, remember 12 is like 12 over 1, so its reciprocal would be 1/12. Reciprocal of 4/9 would be 9/4. And the reciprocal of 3/10 would be 10/3. Okay. One example I didn't put up here that I want to add is if it's a mixed number. So I have 2 and let's say 5/6. The reciprocal is not 2 6/5. Okay, that doesn't work. Can't do it like that. As you might guess, just like with multiplying, anytime we run into a mixed number, we have to turn it to an improper fraction. So you would first turn this into its improper fraction, then do the reciprocal of that. Okay, so remember that, just like for multiplying, it's going to be all about the improper fraction. All right, so dividing fractions, there's a little phrase to remember. It's called keep, change, flip. Okay, so keep means we're going to keep the first number. Whatever the first fraction is, it stays the same. Change means we're actually not dividing. We're actually going to change, and we're going to change it to multiplication. So that's why I'm saying this is a lot like multiplication with one key change, the flip part. So keep, change, flip. So the flip means reciprocal. So remember, a reciprocal is flipping the numerator and the denominator around. So this is going to become 10/3. Okay? So 4/9 divided by 3/10. If I divide by 3/10, that's the same thing as multiplying by its reciprocal. Multiplying by 10/3. So you keep that first number you had, but then you change it and you actually multiply by the reciprocal of the second number. When you get to this point, all you're doing now is normal multiplication like we've been practicing. You look to see if there's anything you can simplify. If there's not, in this case, I'm just going to multiply it. I get 40 over 27. If you want to make that into a mixed number, you can. And that's your answer. Okay, so if we're dividing fractions, we actually aren't dividing at all. We end up multiplying, but we're multiplying by the reciprocal. All right, so I want you to pause it. Go ahead and try this one on your own with keep, change, flip, and then hit play to see if your answer is right. All right, so if I keep, that means the first number stays the same. Be careful. Some people accidentally flip the first number. Don't flip the first number. Change to multiplication, so don't forget to change. You're multiplying now. There actually is no dividing of the fraction. And then flip, I need the reciprocal of this second number, 22/3. At this point I look and, hey look, I can simplify some. I'm just doing normal multiplication of fractions. I simplified that a lot to the point where I got 4 over 1, or that's just the number 4. So remember, keep, change, flip. All right, as you might guess, so now mixed numbers, our most important step, we're going to make them improper. So make mixed numbers improper, just like when we were multiplying. Make mixed numbers improper. Now, what's tricky about this is some people try to do too many things at once, meaning they try to make the numbers improper and do keep, change, flip all in one step. Please don't do that. That's when you make mistakes. First, let's just make everything improper. So I'm going to rewrite it all with division still as improper fractions. Now that I've done that, now I'm going to do my keep 16/5, change to multiplication, and flip the second fraction. Okay. It takes another second longer than trying to do them together, but you're less likely to make a mistake. When you're trying to make them improper and flip it in your head all together in one step, that's when you're going to make mistakes, okay? So please just write down those steps. Take your time so you get the right answer. All right, we're going to look to simplify. They can both be divided by 2, and that's it. So 7 times 8 is 56. 5 times 5 is 25. We can simplify that. That'd be 2 and 6/25, or sorry, not simplify, but turn it into a mixed number. So either of these answers are fine. Remember, you can leave it as an improper fraction. Nothing wrong with doing that. All right, so go ahead and pause it. Try this one on your own. See how you do, and then hit play to get your answer. So 8, remember, any whole number is over 1. So when I do my keep, change to multiplication, and I flip, this now becomes 1/8. Okay, I like to simplify. I can't. So I just multiply, and I get 5/48. So be careful that whole number. For some reason, that sometimes messes people up with the reciprocal. Remember, it's over 1, so the reciprocal becomes 1 over whatever the whole number was. In this case, 8. All right, hit pause. Try this one on your own, and then hit play to check your work. So again, this is over 1. My first step before I do keep, change, flip, it's still division. I'm going to change 8 2/7 into an improper fraction. Okay, so 8 times 7 is 56. 56 plus 2 is 58. So I have 58 sevenths. And now I'm going to do keep, change to multiplication, and flip. All right, so I'm looking to see if there's anything that 21 and 58 can both be divided by. There's not. 3 doesn't go into 58, 7 doesn't, so I'm just gonna have to multiply. So I get 147 over 58. You can turn that into a mixed number if you really want to. 2 times 116, so 31 over 58. But that's another prime example of a time where I'd probably just leave it as an improper fraction. Unless that's a word problem or something where I need it to be a mixed number, I would leave it as the improper fraction. All right, word problems. So a recipe for a loaf of banana bread calls for 2/3 cups of oil. If you have 3 cups of oil, how many loaves can you make? Now, this is a tricky one. The only reason we know we're dividing, I hope you know we're dividing, is because this whole lesson is on dividing. But what can you look for that would kind of tip you off? So you know you have 3 cups, and you're going to divide it up to make loaves of bread for your recipe, okay? And they want to know how many loaves you can make. So you're splitting it up, dividing it up equally, and you want to know how many 2/3 can I get out of this 3, okay? So those are the sort of keywords or key ideas you're looking for when you're doing a problem like this, is splitting it up equally, and how many ways can you split it up equally. That's dividing, okay? So 3, I'm going to write as 3 over 1. And so I can do my keep, change, flip. An important thing I didn't really point out is I know the 3 cups goes first because that's what's being split up. So whatever's being split up is going to be the number that goes first. So now when I multiply, I get 9 over 2. But this is a prime example of where go ahead and make it the mixed number, okay? Because it makes a lot more sense when you're talking about actual real world example to do the mixed number. So I can make 4½ loaves of banana bread. 4 recipes, and I'd have enough for a half recipe if I can split the other ingredients in half. So, which seems logical, so I could do 4½ loaves of banana bread. All right, go ahead and try this one on your own, and then hit play to check your work. All right, so you are wallpapering a wall that is 24 feet wide. If the wallpaper is 1 1/3 feet wide, how many strips will you need to cover the wall? So this is another example where you hopefully know you're dividing because this whole lesson's on dividing. But it's hard to tell, especially for some reason when fractions are thrown in, it's even harder to tell that you're dividing. So sometimes what I'll do when I read a problem with fractions is I'll kind of get rid of them. I'll go, okay, well, what if this wasn't 1 1/3? What if this was 2 feet? And I reread the problem. You're wallpapering a wall that's 24 feet wide. If the wallpaper is 2 feet wide, how many strips will you need to cover the wall? For some reason now I see, oh, that's really easy. 24 divided by 2, I need 12 strips of wallpaper, okay? So a lot of times it's a lot more obvious when you make it into whole numbers. Then when you make it into a whole number, you can just go back now, and what was 2 is really 1 1/3. So instead of writing 2, I'm gonna write 1 1/3, okay? So it's a trick you can use, change everything to whole numbers, figure out what you have to do, and then just sub back in whatever fraction you have. Okay, so I'm doing 24 divided by 1 1/3. How many 1 1/3 are in 24? So first thing I'm going to do, I'm going to turn them all improper. So we got 24 over 1 divided by 4 over 3. Then I'm going to do my keep, change, flip. So do that over here, I'm running out of a little room. 24 over 1 times, that becomes 3 over 4. I look to simplify. 4 goes into 24 6 times. And I multiply and get 18 over 1 or 18 strips of wallpaper. Just remember, over 1 is just a whole number. So 18 strips of wallpaper is what I need to do. So remember those tricks for word problems that help you figure out what's going on. If you're stuck, try and deal with some kind of strategy that I've given you to try and figure out, all right, what do I need to do? What if these were easier numbers? What would I do? And then just plug in the harder numbers that you're dealing with.